So just to cover up binomial expansion in this fragment, I'm just going to keep a brief introduction about the Pascal's triangle and the relation with binomial coefficient, why we call it as a binomial theorem. So the objective is basically understanding Pascal's triangle, uh, Pascal's triangle, and after this, we're going to just quickly touch base upon what is the binomial theorem, binomial theorem, and just understand the evaluation and the link between these two, and of course use binomial theorem to do the calculations and expansions of higher order powers. So as we know the Pascal's triangle, when I just look at the expansion of a plus b to the power 1, it's a plus b. Expansion of a plus b the whole square, it is a square plus 2ab plus b square. Expansion of a plus b the whole cube, as we know, is a cube plus 3a square b plus 3ab square plus b cube. Now Pascal's triangle is about collecting the coefficients. If I have the coefficients, like I can collect 1 and 1. The next coefficient is 1, 2, 1. So actually the logic is that you write 1 plus 1 is 2 here, and then 1 and 1. Then 1, 3, 3, 1, 1, 4, 6, 4, 1. Then if I add up like 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, then attach 1 and 1. Then again, you can keep continuing that way. Now, this is a very helpful triangle to, I mean, expand up till power 5, 6, or 7, because beyond that, it becomes really tedious. Now, for example, if I have been asked to expand, let's say a plus b to the power 20, I might have to write the 20 rows down here, which might be really time consuming. So what's something that can help us? Now, actually, when we look at the binomial expansion, it is a lot about the division of the object or choices that are made. So when I simply talk about, let's say, here, a plus b the whole square, it is a square plus 2ab plus b square. Now, if I give a simple example, let's say there are two marbles getting divided in two people, let's say a and b. There's one way that both the marbles go to the first person, which is one way here. That's why this coefficient is 1. There are two ways that the one marble can go to one person, other marble go to the other person, and then they can be exchanged. That's how you get 2. And then there's one way here to give both the marbles to the second person. So this is how you get, these are the total number of ways to divide them. That's what is the analogous behavior, I can say. Now, if you look at here, a plus b the whole cube, I can say that I can divide or give the first 3 marbles I'm dividing in 2 people. I can give all 3 marbles to the first person. Then I can give 2 marbles to one and 1 marble to other person. And that can be done in 3 ways because I have 3 different types of marbles. And so on here and so on. And this is the total number of combinations that we get. So we have something called as the binomial coefficient, like when you have NCR, which is called as the binomial theorem formula, also n factorial or n minus r factorial times r factorial. This is a formula for doing the NCR. Now, I'm just going to first quickly evaluate a couple of expressions, like how to evaluate phi C2. So it's like read as phi choose 2 or phi combination 2 or phi C2, different ways. So first thing what I'm going to do is I can write down phi factorial over phi minus 2, which is 3 factorial, and then r is 2, which is 2 factorial. Now, just in case if you have no idea about what is factorials, if I want to find out phi factorial, I can write down phi times 4 times 3 times 2 times 1. So 5, 4, 3, 2, 1. If I have, like, let's say 4 factorial, it is 4 times 3 times 2 times 1. So 4 times 3 times 2 times 1. Just be careful about 0 factorial. 0 factorial is 1 actually. So in similar like short explanation, I can just evaluate this part, which is phi times 4 times, I can write down 3 factorial here. So phi times 4 times 3 times 2 times 1 over 3 to 1 times 2 times 1. So this get cancelled and eventually get 5 fours are 20 over 2, which is 10. So this is how you find out the basically the expression of the expression values for the NCR types of questions. Now, when I simply look at now very important result that I get, let's say I'm going to evaluate some of the very important values, which is going to correlate to this triangle. So since I've evaluated phi C2 already, now I would like to just quickly do phi C0, phi C1, phi C2, phi C3, phi C4, phi C5, and let's see if I can link up this with somewhere. So if I do phi C0, it is going to be phi factorial over phi minus 0 factorial times 0 factorial, which is nothing but 1. Phi C1 will be 5 factorial over 4 factorial times 1 factorial, which is going to be 5 if I simplify. Phi C2 is going to be, already we did it here, so it was 10. So I'm going to take 10. Phi C3 is 5 factorial over 2 factorial times 3 factorial, which is again, I'm going to get 10. Phi C4, you're going to get 5. And phi C5, you're going to get 1. So now if I write down these numbers in a particular order, what I get is 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. So this is basically nothing but the Pascal's triangle for the fifth row. So if I can just summarize this here, if I say 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Instead of writing like this, I can write down, okay, 1C0, 1C1, 2C0, 2C1, 2C2, 3C0, 3C1, 3C2, 3C3. So if you have like a fifth row, I can write down 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. So this is how you write down the expression for the fifth row. So you don't need to write down actually anymore the Pascal's triangle or these numbers. So if I have to write down the Pascal's triangle for seventh row, actually it is going to be 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, and 7C7. If you evaluate this, you're going to get straight away the expression values. Now assume that if I'm expanding a plus b to the power 7 here, a plus b to the power 7, it is going to be a to the power 7, a to the power 6, a to the power 5, a to the power 4, a to the power 3, a to the power 2, a to the power 1, and a to the power 0. Here it is going to start with b to the power 0, b to the power 1, b to the power 2, b to the power 3, b to the power 4, b to the power 5, b to the power 6, and b to the power 7. So here we have last expression. If you add it up, you straight away do get the answer. So you didn't even need Pascal's triangle for this. And of course, you got to simplify what's value 7C0, 7C1, and so on. So this is now coming up with some observation. Let's come up with some observation here that if I had to find out the first term, I'm putting this value 0. Second term, I'm putting this as, this is my second term. This value is 1. Third term, this value is 2. Fourth term, this value is 3. So I come up with a formula that if I have to find out a particular term of this expansion, let's say T1, I can straight away say, okay, this is my n. So it'll be NCR, a to the power n minus r, b to the power r, if you agree. Because like a to the power 7, b to the power 0, a to the power 6, b to the power 1. So this is what is happening. Now, in this case, if I plug r as 0, I get my T1, which is first term, because if I plug r as 0 here, I get NC0, a to the power n, b to the power 0. So you can clearly see that is correct here. If I wanted to find a second term, I can get it as, let's say I plug r as 1. So 1 plus 1 is T2, which is 7C1 for our this question. If I wanted to find out, let's say taking n as 7, a to the power 7 minus 1, so n minus r, so 7 minus 1, and b to the power 1. So this holds quite true for these results. So in case, to generalize, if you have a plus b to the power n expansion, TR plus 1's term formula is given by a to the power n minus r, b to the power r straight away. And don't forget to add the NCR coefficient, where if you plug r as 0, you get first term, r as 1, second term, and so on. So taking an example on this skill, if I have, let's say, x squared minus 4 by x to the power 20, and just to conclude here, if I wanted to find out how many terms are there in this expansion, in total there'll be 21 terms. So if I wanted to find out, let's say, eighth term, if I wanted to find out the eighth term on this expansion, so eighth term is basically going to be, we are going to plug r as 7. So T7 plus 1, which is T8, that's what I want, is 20C7 x squared to the power 20 minus 7 minus 4 over x to the power 7. So if you simplify this expression, you're going to get T8, the eighth term. So this is very common example that is asked in standard level and higher level math. Just taking some higher order thinking questions, which are asked in IB. So let's take an example from the textbook straight away. So here is the question. Let's take this example. All right. So the question here is that find out the coefficient of x to the power 6 in this expansion and the constant term. So in such cases, what we basically do is, we really don't know which term is the constant term. Either you do the different permutation combination of which term is going to be constant term, or just assume that you don't know the r value. So first I'm going to generalize the TR plus 1, the term formula. It is written out here. So my n value is 12. So 12 CR. I'm not putting any r value because that's what exactly you don't know. So 12 CR, then you're going to write down x squared to the power of 12 minus r and 4 by x to the power r. So I'm going to simplify after this. Okay, so 12 CR x to the power 24 minus 2r times 4 to the power r over x to the power r. So it is going to be 12 CR x to the power 24 minus 2r 4 to the power r x to the power minus r, because if you bring it up, so now you simplify this and it's going to become 12 CR x to the power 24 minus 3r, because if you add these powers, they become 24 minus 3r times 4 to the power r, which is exactly the same thing as we got here. So coming back to how do you find out the coefficient of x to the power 6? So to find out coefficient of x to the power 6, basically this power should be equals to 6, as simple as that. So you're going to just equate this to 6. So I'm just going to do one thing, is I'm just going to equate this power to 6 and get my r value. So I'm going to get r as 6 here. So since you got r as 6, it means that it was T7 actually. The 7th term contained x to the power 6 term. So the 7th term is something that I had to find out. Now since I got r value, just plug here. It'll be 12 C6 4 to the power 6, and automatically it is x to the power 6 because if you put r as 6 here. So this is the value that I wanted to calculate. That's the coefficient of x to the power 6. Now first, now to find out the constant term, you are going to equate this to 0. So 24 minus 3r, you're going to equate to 0. So this is a very common link where here r is basically 8. So 9th term is actually the constant term. Okay, so 9th term is the constant term and its value, you're just going to plug r as 8 here. So it'll be 12 C8, 4 to the power 8, and x to the power 0, because eventually we got this by equating to 0. So that's how you do this kind of basic question, and more challenging questions we're going to take in the next fragment.